Okay, I think we are recording. It's been a while since I have recorded a YouTube video actually. And yeah, I think I was just going to make this video just summarizing my third semester, the projects I made. And if you are seeing this, maybe you can share some of the projects you made. And if you want to check any of these projects, I think you can just check my GitHub that will be given. Or you can just copy the link from here. Anyways, I think I mostly wrote a lot of Golang, C++, and Java this semester. Golang being my favorite, obviously. Anyways, let's start. So, these are. Oh my goodness, that's embarrassing. Yeah. So this is a poker engine. It's written in C++. It's not a very efficient GTO. So GTO stands for Game Theory Optimal. So this is not a GTO, so it does not predict every win, or it's not like an engine that keeps on improving itself. That's like the ideal poker engine that someone would write right now, something that uses rules, etc., neural nets to get better results and deep learn the patterns. But this is not that. This is actually very simple in sense. This just simulates the cards which are in the deck still, and it simulates them and tries to get a win and loss percentage. So the only reason I wrote this was because I was very interested in poker, not playing the game, but in the theory, in trying to win the hand, the probability and the statistics, the mathematics basically. Yeah, so this is not very interesting project, but yeah, I think it's still difficult, and it's pretty hard to model the cards, the deck. The GUI is pretty simple, and of course the game. I think you need to ultimately simulate the entire poker game. So everything from a hand to how the hands are evaluated to how a three in a row is evaluated. Basically everything needs to be evaluated, and needs to be evaluated fast, because doing 100k trials is not very easy, especially doing it on my system. I don't have a lot of resources to run a lot of trials. But yeah, I think I wrote a pretty simple program. I think if you read the source code, it's not that hard. It's not a lot of optimizations also, not a lot of compiler optimizations, or even just a lot of code optimizations as well. Anyways, that's it for the first project. Let's talk about Tolstoy. Very impressive project. I'm really proud of this. So it's inspired by Kafka. It's a pub subsystem. It's heavily inspired by Kafka, but it does not use the polling that Kafka does. It uses WebSockets, because those were the simplest that I could implement. Also, I migrated to protocol buffer, so uh, which in the first version, I believe, I think, what is this version? So yeah, this in the first version, I was using a very naive approach of using binary protocol. So yeah, you can see this was the first version, first protocol, which was type, topic and payload. But I soon realized that it's not actually very possible to write a complete system with this, because especially because of the packet types. There are a lot of packet types. You can see acknowledgement, error, server, publish, etc. So yeah, I generally moved to protocol buffers. It was simple, and it's actually pretty interesting how protocol buffer works. Yeah, so this provides two agents. Agents are basically a way to publish or subscribe. So publish agent and subscriber agent, and there is a broker that you run. Yeah, it also has a config file. So this is of course this is also inspired by Kafka. So port, host, topics, etc. You can say this is a very combination of the MQTT protocol and Kafka, because it uses almost entirely the architecture which Kafka uses, apart from the polling, and it uses a very simple binary protocol buffers protocol to talk, which is like MQTT inspired. Yeah, it also has persistence, and I think almost entirely done. Yeah, I think I've forgot to update the README file, but yeah, I think offsets are implemented, and pause and resume are also implemented. I think this was, I think, one of the first projects where I also had to implement unit testing, since I figured everything just keeps on breaking. It's better to write unit tests and test it out. Not like I did a great job, but anyways. So apart from this, I wrote, what did I do? Yeah, it was a good project to learn about concurrency, on how concurrent systems work, why you need mutexes and how mutexes work. And it's not actually that simple to implement even a basic system. You can see that I have 165 commits, which is actually surprising. But yeah, so this is another project, really proud of this one. And then Quark. Yeah, this is another impressive project, I think. Most of these projects sound very impressive, but if you actually try to do it yourself, you will realize that they aren't actually that hard to do. But yeah, it's super rewarding to learn new things and implement something like this. So this is a programming language. This is more of a compiler. It works on the JVM, obviously. So it generates the dot class file that JVM ultimately accepts. And yeah, I think it implements almost everything that you need to solve a basic code forces problem or a basic lead code problem, like loops, functions, expressions, control flow. Almost, yeah, I think it does implement for loop, break, and etc. Also structs, ios. Yeah, I mean, I was just implementing stuff which I thought was easier and which I could easily visualize on how to implement. Yeah, the only thing is it uses Antler, so it's not a custom parser. It uses a parser generator to generate the parser and the AST. So I believe there is a grammar file somewhere in the source. I believe, yeah. So this is the grammar file. You can see that this is the parser grammar. These are all the statements that can be done, and these are the lexer rules. So it supports int, string, bool, double, constant, and symbol. Yeah, it's okay. It's actually pretty interesting to write this as well. Writing a programming language, I think, is it's a tough job in itself, but using a parser generator makes it very simple. Also, this uses ASM library. I think there is jars. Yeah, so you can see that this uses a ASM library, which is basically used to generate Java bytecode instructions. So it's not like I'm generating the instructions or writing them in the binary file myself. I'm just pointing it to the ASM, and then the ASM generates the file. Also, I don't have to keep the stack count manually, and just a lot of bunch of things that you need to make sure for a valid dot class file. So yeah, I think it's not very impressive if you try to write it, but yeah, it was a pretty good learning experience, especially understanding how ASTs work. How do you actually walk through AST? How do you generate code? I think once I have written a compiler, I think writing an interpreter seems pretty easy now, especially using a parser generator. Obviously, writing a interpreter doesn't sound a lot harder. Anyways, so CPU scheduler. So this is again a very simple project. This is a class. This implements the classical OS algorithms that would be taught, that also were taught to me. So first come first serve, shortest job first, etc. And priority based algorithms. I think these are also implemented, but I just haven't updated it. Also, it has a script.py which generates the Python. It generates the plots. I think it uses matplotlib to generate the file, generate the graphs, basically the Gantt charts. Yeah, apart from that, I think it's pretty straightforward. I think not very impressive, but yeah, it's fun. And actually, one of the few projects that took me less than a few days to write. I think, yeah, I think it took me like 5 days, 6 days, also like 15-20 minutes each day. Draw. Yeah, so this is a scribble.io clone. The only reason I wanted to make this was I wanted to make a full stack project involving Golang and React. I eventually decided to write TypeScript, so I think if you see the first version, which is this one, I don't, yeah, don't ask me why I named it Paneer. Go to my Twitter, I'll tell you there. Anyways, so yeah, the first version was written in React, JavaScript, but eventually I decided to write it in TypeScript. I have no reason why, no solid reason, but yeah, it was just fun. Not fun writing, but yeah, just fun migrating. Anyways, so this uses WebSockets and all the fancy stuff to communicate to the Golang web server, and there is a web server which runs, it sends all the drawing data. So whenever someone draws on a tab, it gets sent, obviously. Yeah, this is also a fun project. Obviously, this is very, very incomplete. Like, a lot of stuff is incomplete. Even the UI is pretty incomplete, obviously. But yeah, I think I've got a basic skeleton of the project ready. I think I can modernize it and furnish it if I really want to. A lot of error handling is required in this project again, like random disconnects and just a bunch of things that would make the game a little more playable and enjoyable. But yeah, I think this was another nice project. Had to write a lot of React in this. I don't normally write React or any kind of front end because I just don't enjoy it, which I should be changing. Anyways, uh, JSON pass. I think this is the most recent project I have worked on. I think let's see. Yes. So yeah, 2 weeks. It's been 2 weeks roughly. So this is a basic LL1 parser. It was fun because I always wanted to learn how parsers work, especially because I could not write one during Quark. So when I wrote Quark, I tried to write a parser, but I was just not very successful. So of course this is a LL1 parser, so you cannot write a complete programming language using an LL1 parser. You obviously need a recursive descent or you need a LLK, so random look arbitrary look ahead parser. But yeah, I think LL1 works. Also, it works for a simple JSON file. The only remaining thing is I need to implement objects in itself. So recursive objects are not applicable or not implemented basically. Yeah, apart from that, everything is implemented. I think any valid JSON can be interpreted or parsed. And yeah, it generates, I believe it generates a tree. It generates a runtime data structure JSON value. Wait, I think we'll try to find it. Just a second. Yeah, so it uses the natural LL1 parsing table and generates the parsing table and uses a stack to try to parse. Yeah, yeah, so it uses a vector JSON pair runtime. So this is all generated at the runtime when the code is started parsing, when the code starts parsing. Yeah, you can see that this is a JSON value struct which it uses. Yeah, it's pretty usable if you actually want. I haven't tried it using it in proper environment or proper tests, but as much as I could try, it did work for the most part. Also, I really just wanted to implement the LL1 algorithm, the parsing algorithm, which was pretty successful. I haven't tried it with proper JSON or like a lot of JSON basically. Anyways, side quests, these were like smart pointer implementation, not very exciting. These are like few hundred lines of code. This was also simulation of computer graphics, so like a few algorithms that are used in computer graphics, I don't think they are used, but they are just basic theory. I also simulated and implemented them. This is not very exciting. I haven't, I think, even put this on GitHub yet. Anyways, so let's talk goals for next semester. Roughly, apply for internships. Obviously, I think that's the main goal. I think they are in order, so the goals are in order of how I want them or how much priority. And then more problem solving, obviously. 3-star code chef, I think I reached 3-star. I mean, I'll try to reach 3-star before the year ends, so before the new semester starts. And then more problems on lead code. Yeah, I think this is just going to be there constantly until I pass out, and even after that, let's see. Rust, yeah, I think I'm really excited to learn Rust. I think I've been delaying this for a very, very long time now. I think it's almost been 2 years now since I have been trying to get into Rust. Ever since the Web3 Rust era, I've been trying to get in, but it's just not happening. I'll see if I can get into Rust and make a few projects, at least understand the code, why Rust is famous, borrow checkers, etc. Get into AI again. This is not to get into the core AI or deep learning, machine learning, whatnot. This is just into Gen AI and LLMs, and to satisfy my curiosity in just in general how it works, etc. So maybe writing like a tiny LLM or inference engine or something like that. Transpiler for Quark. Yeah, I think I also tried working on this. I think I might have started the work, but I just haven't finished it. Maybe. But yeah, writing a compiler and is easy. Interpreter is also pretty easy once you write a compiler. I think transpiler is the logical next step after writing a compiler, probably. Chess engine, yeah. So these are just projects that I really want to work on, and this is finance-based projects. I think there aren't a lot of trading finance-based projects apart from order books, matching engines, and I think I think we can update it and write backtesting engines. Backtesting engines, basically. Yeah. So backtesting engines, better social life, and more sports. Yeah, of course, it's second last according to priority, and study for GATE. Again, this is not confirmed because I have not yet confirmed if I really want to give GATE. Also, I have some time before I can actually make a decision and start seriously if I really want to. But yeah, I think that's about it. Hopefully, next semester will be better, even better, as a matter of fact. Yeah, and hopefully I'll come to this video again and see how far I've progressed.